right, friends, let's talk about using proofs with converses. So if we have alternate interior angles, alternate exterior, or corresponding angles, and we say that they are congruent, or if we do consecutive interior, consecutive exterior, and we say those are supplementary, then those lines are parallel, that the transversal is crossing. So how does that work in a proof? Let's take a look at this first proof right here. Okay, so given that angle 4 and angle 5 are supplementary, we need to prove that J is parallel to K. So we know angle 4, that's this guy right here, and it might help if we highlight these so you can see them a little better. Angle 4 and angle 5 are supplementary. Okay, so angle 4 and angle 5 are supplementary, which means the measure of angle 4 plus the measure of angle 5 is 180 degrees by the definition of supplementary angles. Def of supplementary angles. Okay, because those are 180 degrees and because they are supplementary, that means J is parallel to K, and you want to give the relationship. So those are consecutive interior. So you're going to say consecutive interior angles, angle converse. So if your proving lines are parallel, you got to throw the word converse over here. Let's try another one here. Okay, so we have, throwing all the answers right in front of you. There you go. All right, given angle 1 and angle 2 form a linear pair, and angle 1 and angle 4 are supplementary, prove that A is parallel to B. Okay, so we're going to be proving that some parallel lines, we're going to have to use that converse. We're going to find that angle relationship and use that converse. So the first thing we're going to do is write our givens down. That's our easy one. We know that angle 1 and angle 2 are supplementary, form a linear pair, and the measure of angle 1 and the measure of angle 4 are supplementary. Okay, so what should we do next here? So that means that if angle 1 and angle 4, or angle 1 and angle 2, those guys are also going to be supplementary. Angle 1 and angle 2 are supplementary. And that's because all linear pairs are supplementary. That's supplementary. That is your linear pair theorem, or linear pair theorem is, I believe, what we've been calling it. So for our linear pair theorem. Okay, so for number 3 then, let's see what else we can do here. So for number 3, now that we know angle 1 and angle 2 are supplementary, what we really want to do is say that if we say that angle 1 and angle 4, actually without even saying that part, we can say angle 2 is congruent to angle 4, okay, so angle 2 is congruent to angle 4. And here is why. This is called the congruence supplement, I can't say it at the same time. Congruence supplements theorem. Okay, so what that means is, if you take a look, angle 1 and angle 4 are supplementary, angle 2 and angle 1 and angle 2 are supplementary. So if angle 1 and angle 4, angle 1 and angle 2 are supplementary, 4 and 2 have to be the same. And that's just because they're going to be congruent, because if we have something is supplementary, let's say one of them is 150 and the other is 30. So if this is 150 and this is 30, they're supplementary. Angle 1, like I said, is 150. If this is 150, this has to be 130, or this has to be 30. So 4 and 2 are congruent. That's called the congruence supplements theorem. Is the best way to think about that. Now that I've said that angle 2 and angle 4 are congruent, so angle 2 and angle 4 are congruent here. What we can say is, okay, looking at that, that relationship there is corresponding angles. And if corresponding angles are congruent, then those lines are parallel. So what we can say is, hey, line AB is line A is parallel to line B. That's A and B. These guys are parallel because of corresponding angles converse. So converse, corresponding angles converse. So if you're proving that they are parallel, make sure to throw the word converse in there. You're looking for that angle relationship and then putting converse at the end of it. Hope this helps.